Okay, question 15. The graph of y equals 4 take away x for values of x from -2 to 5 is shown on the grid. So this graph here has already been drawn for you. It's this line here. On the grid, draw the graph of y equals 2x take away 5 for values of x from -2 to 5. So what they're looking for here is for you to draw a table of values. And you've got to have values of x going from -2 all the way up to 5. There we go. And we've then got to find out what the y values are. Now when you're doing these, I would suggest you start at the right hand end of the table because you've got positive numbers up there. Our rule is y equals 2x minus 5. So here x is 5. So we would do y equals 2 times 5 because x is 5, take away 5. If we work that out, 2 times 5 is 10, take away 5 gives you 5. For the next one, we've now got x being 4, so y is 2 times 4, take away 5. 2 times 4 is 8, take away 5 gives us an answer of 3. And you can carry on through that table working out those sums. You will also see a pattern. As you go along these numbers here, you will see a pattern. So you'll be able to quickly stop doing these calculations here and just use the pattern to help you to finish that off. When you've done that, you'll then have to plot your coordinates. So here we have got coordinates x is 5 and y is 5. So on your graph, you would then plot the x is 5 and y is 5. So you'll plot across there. The second one we've got is x is 4 and y is 3. So we will plot 4 in the x direction, 3 in the y direction, which means that would end up there. You can plot the rest of your points and draw your graph. Use your graph to solve this equation. Well, that's going to be where the two graphs meet, and you're looking for the value of x where the two graphs meet. That's now getting quite complex. Question 16. BCD is a straight line. So we're told that this is a straight line. It looks like it, and it is. Although you can't take things for granted unless you're told them, because this is not drawn accurately. So just because something looks a certain way doesn't mean it is unless they tell you that it is, like they've done here. BCD is a straight line. The next fact we're told, and this is a really important one, is that triangle ABC is equilateral. So think what equilateral means, because that tells us something about these three angles here. Equilateral means that all the sides of the triangle are the same length, which also means that all of the angles are equal. So you should be able to find the size of each angle in this triangle, and that one I've put an arrow on there would be a really useful one to be able to find. So if it's equilateral, what's the size of each angle? We're also told that CE equals DE, so it's saying that this line here is the same length as this line here. And they've been helpful because they put a little mark on each line there and there to tell you that they are the same length. And that means that this is an isosceles triangle, meaning that because the two sides are the same length, these two angles are the same. So you can now use your facts you know about triangles to use all three of those angles to find the missing angle at C. 16b. Amber is working out the size of an interior angle on a regular octagon. Now an interior angle is this angle here. Her method, she says an interior angle equals 360 divided by 8. So we could start by working out what 360 divided by 8 is, and it's going to be 45 degrees. So 360 divided by 8 equals 45 degrees. Now we can tell straight away by looking at that it's not a 45 degree angle, because 45 degrees is what sort of angle, and the angle drawn here is what sort of angle. So you can say that it's not correct because they're two different types of angle, but you need to be able to name the types of angle. The other thing you could say is that actually the sum they've done isn't for calculating an interior angle, it's for an exterior angle. If you wanted to find the size of this angle here, you would do 360 divided by 8. So you could then work out what this angle actually is. That would be another way of working that out. So complete that answer. Question 17. Here is a map of an island with cities A, B and C. The straight lines represent roads. So we have got a road here, we've got a road here, and we've got a road here. We're also told that A is due west of B. So A, this point, is west of B. So if you stand at B and you face west, you would be facing A. It says now to write down the bearing of A from B. So we want to find the bearing of where this point is from this point. So this is where we're starting here at B. So let's get rid of this. So if we want to find a bearing, we need to start by facing north. So our north line goes on there. And we have got to turn clockwise to face the direction we're looking to find the bearing of. So we want to find where A is from B. We have to start at B facing north and turn clockwise. And that is your bearing, that angle. So you've got to figure out what that angle is all the way around there. Part B. Umar drives from A to B on the route shown on the diagram. So Umar drives from A to B. And Kaz drives from B to C. And we've got to find out how much further Umar drives than Kaz. We must show the working out. So we're told that, we've got to do some measuring because we've got to work out, we've got to use the scale. We've got a scale here. 1 centimetre is 200 kilometres. So we can work out the length of AB. The length of AB is, well, they would accept between 6.3 and 6.7. So AB, they would accept between 6.3 and 6.7. We'll do 6.5. And then you've got to find the distance that Kaz drives from B to C. So if we go back, you've got to measure length B and length C and add them up. And you should come to something between 4.5 and 4.9. So BC is 4.5 to 4.9, so we'll use 4.7. But if you get between those numbers, then you will get the marks to begin with for measuring those lines. Now we want to know how far they actually travel. Well, 1 centimetre is 200 kilometres. So for the first one, you would do 6.5 centimetres times by 200 kilometres. And that would tell you how far Umar drives from A to B. You can then work out how far Kaz drives from B to C, and you can work out how much further Umar has to travel compared to Kaz. Question 18. A shop sells raincoats and umbrellas. The scatter graph shows the monthly sales for 12 months. Write down the type of correlation shown by the scatter graph. So correlation, we're looking for positive, negative, or no correlation. So you'd write down positive, negative, or none on that line. Some people have described the relationship. They've said as the sales of raincoats increase, the sales of umbrellas also increase. That's not what we're being asked. We're being asked for positive, negative, or none. 18b. The manager expects the sales of umbrellas next month to be £60. Draw a line of best fit to estimate the sales of raincoats next month. So a line of best fit is a line going through these crosses and keeping them roughly evenly spaced either side. It doesn't have to go through any cross in particular. You just need to keep them evenly spread either side. So if I draw a straight line, I'm going to go start here. And you have to use a ruler for this. And I reckon that's a pretty good line. Could maybe do a little bit further down because I've got some quite big gaps between these here and very small gaps here. So I reckon that I could just move that down a touch if I can remember how I do it. I know. But if I cut this, right, so that could do it just moving down. I'll try again. That could do it just moving down a little bit. So as I've got the crosses roughly evenly spaced. Now in the mark scheme, it actually tells the examiner what they're allowed to give and what they aren't. And it will allow you the marks if one end of your line is between 10.35, so 10.35 is there, and 10.55, so 10.55, 35 is about there, let's do that, 10.55 is there, so my bottom end of the line is right, there we go, because it passes between those 2 points, and the top of my line has got to be between 70, 135, so that's, oh, I'm just on it there, so that's 125, 130, 135, I'm just on it. And what else was it? It was 70, I'm trying to find the numbers here. Ah, 70, 155. So 70, 155, which is there. So provided my line passes between them, which it does just, I'll get the marks for it. Okay. I've got to use that line of best fit. The manager expects the sales of umbrellas next month to be £60. So here's my umbrellas on the horizontal scale. So it expects the sales of umbrellas to be £60. So I read up to the line. It's not quite landed in the right place. Read up to the line, there we go. And then from there I can read across to the axis over here. And I can estimate my sales of raincoats if the umbrella sales were £60. Question 19. Multiply out that bracket, but we did this using grid method, so I'll work out, I've got some space down here. So, let's turn these shapes off. So we did a grid method for this. We said x is multiplied by x, take away 4. So you can work out what goes here and what goes here. Then they can find out your correct answer out of those 4 there. So we've got a ratio here. We've got ratio of A to B is equal to 5 to 2. How many times larger is A than B? And circle your answer. So if we had a ratio of A to B is 5 to 2. We want to know how many times bigger this number is than this number. So what would you have to multiply 2 by to get 5? And you can try out different things because you've got a calculator. So you could do 2 times 0.4. Does it give you 5? 1.5 times 2. Does it give you 5? 2.5 times 2. Does it give you 5? 3 times 2. Does it give you 5? And so on. A circle has a radius of 4.2 centimetres. Work out the length of the circumference. So your formula for circumference of a circle is pi times by diameter. So you're given the radius of the circle. So you first have to recall that if the radius, that's there, is 4.2. The diameter goes all the way across the circle. So you've got to figure out how long this diameter is first of all. And your equation is that the circumference is pi times the diameter. So you can write out your sum and work it out in the calculator. Part B, the circle has a centre 0. Draw a sector on the circle. Well, it's just knowing your different parts of a circle here. We've already mentioned a radius. We've already mentioned a diameter. We have a chord, which goes joining two parts of the circle. We have a segment, that's this bit. This is a minor segment. And on the other side, all the other side is a major segment. And a sector is this bit here. So a sector is like a slice of pie. So that would be a sector there. Oops. Like a slice of pie. So there we go. That would be a sector. So if you were to draw that, you wouldn't draw in everything I've done. I was just going through parts of a circle. You would just go something like that. Just draw yourself a wedge. Use a ruler. Okay. Question 22. 2 ordinary fair dice are rolled. Complete the tree diagram. So if a dice is rolled, getting less than a 3, it's an ordinary fair dice. Let's write down the numbers. So we've got 1, 2, 3, 4, 5, 6. So the probability of getting less than a 3, well, that's the probability of getting a 1 or a 2. So that is 2 numbers out of 6, which is the same as 1 out of 3, which is where they've got that from. So what then is the probability of getting 3 or more? So here's 3 or more. What's the probability of getting 3 or more? You could also work it out by remembering that both of these branches, this one and this one, must add up to 1. So that's a second way of working out the probability that goes here. And if you've rolled the dice once, rolling it a second time gives you exactly the same probabilities. 22 part B. Work out the probability that both dice land on a number that's less than 3. So for both to land on a number less than 3, the first thing that must happen is this, and that has a probability of a third. And the second thing that must happen is this, which also has a probability of a third. So we've got 1/3 for the first roll and 1/3 for the second roll. You now have to think what you have to do with them to be able to find the probability of this happening and then this happening. Question 23. We'll do on the next